Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Indrayani from Civil Engineering Department, State Polytechnic of Sriwijaya, and my partner Reni Citra Ramadhani. Okay, I would like to present my paper with the title Design of Microhydro Power Plant Prototype Based on the Kelekar River Flow Discharge. Okay, I will start my presentation. Microhydro power plant is renewable electrical energy that is environmentally friendly since this plant uses water as its driving force. Indonesia has a very large potential for water source so that this hydroelectric power plant can be developed as a superior energy source. One of the rivers in South Sumatra province that has the potential to be developed as a source of microhydro power is the Kelekar River, which is located in Ogan Ile Regency. The Kelekar River is watered by the existence of the Embung of Sriwijaya University, which has a spillway designed with two sluice gates and a peak elevation of 6 meters so that the existence of this embung can support the utilization of Kelekar River was as a microhydro power plant. There are several studies related to the development of microhydro power plants have been carried out utilizing river flow in Indonesia, including the first in Ngatang district, Malang Regency, and the second in the Wai Besai River, West Lampung Regency, and the third in the Uwe River, Jayawijaya Regency, and maybe some river others. Methodology in this study, you can look this picture is microhydro power plant design. This is a structural design approach. Have the some component that is turbine, water circulation pump, water reservoir, flow meter, technometer, multimeter, AC generator, clean water reservoir, and all the process start from design, assembly, and testing was conducted at the Sriwijaya State Polytechnic Laboratory. And the step testing procedure, the first, preparing a prototype of a microhydro power plant and then filling 200 liter water and then connecting the instrument socket to the electricity. After that, turning the switch to the start water pump and then turning the button on the multimeter and technometer to measurement process and fully opening the valve until the 100%, observing the process, and don't forget to recording data. After that, after completing the experiment, closing the valve to stop the flow of the water to the turbine and turning the switch to stop the process and finish process. Okay, you can look at this picture. This is a location of Kelekar River and Embung of Sriwijaya University. The design of this microhydro power plant prototype is based on the flow of water in the Kelekar River, which is located in Ogan Ilir Regency. And the figure third spillway at the water gate of the Embung of Sriwijaya University. You can look in this picture. The water flow velocity is based on the height of the water falling on the spillway at the Embung Sriwijaya University floodgate. And the figure fourth spillway descent cross section. Data prototype designed from previous study that is design discharge of 0.45 meter cubic per second, high effective energy of 3.4 meter, the power of water flow of 15.3 kilowatt, the power generated by turbine of 11.5 kilowatt with turbine efficiency of 0.75. All this data will be used as the basis for designing of prototype. And then this picture you can look, this is result of microhydro power plant prototype design. In figure 5, you can look a front view of the microhydro power plant prototype, and the figure 6 you can look side view of the microhydro power plant prototype. The result of the prototype experiment, you can look in this table the performance result of the 19 blade turbine using 4 millimeter diameter nozzle. We have the four variation lamp load 0, 5 watts, 10 watts, and 15 watts. From the result of the experiment, it can be calculated that the discharge gained by the prototype of the microhydro power plant, namely discharge used, is 0.0000145 meter cubic per second. The spray speed is 23.078 meter per second, and the power produced is 4.944 watts. The last conclusion, based on the experimental data on the prototype of a micro hydropower plant using 4 millimeter diameter nozzle, the discharge of 0.0000145 meter cubic per second, the spray speed of 23.078 meter per second, the resulting energy is 4.944 watts.
I
Thanks
would like
for
to
your
thank
great
you all for
attention.
taking time to listen to my
Assalamualaikum
presentation.
warahmatullahi wabarakatuh.